All right, so let's look at the situation with your daylighting analysis. What's going on is that you are having some windows or some glazing that is letting light in and others that isn't. Um, we can make that clear by turning off the program, everything except for the glazing. Um, and so we can see that, yeah, some glazing seems to be working, others not. But also even here, if I look at, so this is the west side of the building. And let me go and just ghost it. Let me turn back the building on. There should be no reason why this piece of glazing is different than these. These all seem, uh, this glazing, the large glazing here, and this glazing here are different than this one. So there's just something up, right? And the question is what? So I was able to fix your model. And the way I did it was to rebuild it. So let me just, so I'm going to give you that model. It's here. So I did a bunch of things, and there was a lot that I was changing, and just because I had to go quickly, I couldn't keep track and do tests to make sure that that I understood what was happening. And I think this is one reason why this can be difficult for architecture students in general, is that you're not thinking in terms of building things systematically and in troubleshooting as you go, and so you build these models that are complicated. I mean, geometrically, where maybe there's things that are overlapping. There's so many places where things can go wrong, and then it becomes hard to troubleshoot it. So, my then general comment to you is that if you're interested in running simulations moving forward, just realize that, and this is what I've been trying to say, that you have an architectural model that these daylighting layers are based on, right? I guess it's this. And that's great. You're doing exactly what I asked you to do. This, though, remember that then the question is, what in this model do we need to do daylighting? And the first thing I noticed is that you had everything grouped together, and this includes your windows. It's all just one big GOM. And then and so I couldn't even tell really what was going on. I had to ungroup that. And then I had to ungroup again. So there's multiple layers of grouping. Then once I've already hit ungroup twice, and now I've got these large sort of blocks of building that are not really related to one another in a way that I can tell. I think it's because there's a floor plate in here that you're using, and then you somehow decide that you should group everything based on that. I think your windows typically are in groups, right? And here we have 3 groups. So I'm not saying that any of that is wrong and that Climate Studio is not going to be able to understand it, but let's just remind ourselves what a daylight availability analysis is. What we need is, actually I'm just going to, well, no, I'll just do it here. I need, so I'm noticing sometimes it takes me quite a while to do anything in your model, and I think it's because if I have a simulation on, you've got a huge amount of work surface here, and I think just when that graphic's on, it slows me down. I'm not positive that's what it is, but so I typically will turn off my results when I don't need to use them. But let me go back to what I was doing. So daylight analysis is a simple concept. We have some stuff that is either blocking or reflecting the sun. So in this case, if I had a ground plane, that would be reflecting the sun. If I had buildings around this, they would be blocking and reflecting the sun. And then my opaque envelope is blocking the sun, right? So that's the first thing I need. And then I need a window. I need so that's stuff that's interacting with the sun in terms of blocking it or reflecting it, and then you need something that's letting that sun in, and that's some kind of glazing, right? So, and it needs to be either coplanar with the opaque envelope, or you could have a hole in the wall, basically because a hole is going to let light in. So there's this methodology in Climate Studio where they're saying, look, we're not going to make you cut holes and everything. If you put a plane on top of a plane and you call one transparent to sun and the other not transparent to sun, we will understand what you mean. Um, However, you can always just make this, you could just cut a hole in this model that was this size, and I would guarantee you that the sun's going to go through that. So that's one. Uh, that's a troubleshooting method if you're desperate or not desperate. If you're like, look, I just want to get this working, you could I could explode this. Um, oops, spelled it wrong. And then I could cut a hole in this surface with this other surface, and I guarantee you that the sun would go through. Then the one other thing we need is, as you know, inside we need a surface that we can use to analyze how much sun is hitting whatever place we want it to be. We want to measure it based on. So that's the three things we need. And so I know you already know that, but my point is that then you have a lot of other stuff going on in your model, or you're not doing it that simply. And so I have all this overlapping stuff. I have all these things grouped together, and somewhere along the line when you were building that, it caused problems. And that's all I can say. So what I did was I went back and the first thing I did was I exploded everything. Now, I'm not saying it's the best way of doing it. I could have gone back and just rebuilt. I could have step by step just said, okay, I'm gonna make a volume here, and yeah, I'm not sure why this is so slow right now because I don't have a result on. So it might just be, I don't know what it is, but okay. Let me go back to this. I was just saying that I could rebuild it in a variety of ways, but the point is, all I need are the exterior surfaces that are opaque to the sun, exterior surfaces that are going to let the sun through, something for the sun to hit inside, and then partitions that are going to block the sun inside. And that's one thing you've done is you've combined your partition. Oops, let me go back to your model. Sorry, I'm going back and forth. Like for example, in this block, I've got interior partitions, exterior wall, floor plates all together. And then I think there were cases I found where you had doubles of these things that might be causing a problem. I could see how if you have something that's a group that has three different types of materials and surfaces that would confuse the model. So just simplify and try to get in the habit of only putting in your simulation model what you need for that simulation. And so you're building it on your architectural, but it's not the same thing. So what I did is I exploded everything. I just left them exploded. I wouldn't need to do that. I could recombine them. One advantage of this is that then if I go and I created an opaque and a partition layer here. I'm going to turn off my work surfaces so this is just really clear, and I'll turn off your glazing. So I went in, and this is not by no means perfect because there's a lot going on here, and so, but I just wanted to make sure that I had, like I have a hole here. I'm noticing now that's not. I'm not. I would need to fix that. Oh, so I think that might be from these other. Yeah, so that would be fine because that's going to be filled with these other programmatic elements, but they would also then need to have materials applied to them. I'm not sure if you did that or not. Let me do that quickly here just so we know what we're talking about. We want to have our egress and our horizontal circulation. They also have to have materials because if they're somehow interacting with the sun in a way that there's a window involved nearby, then I'm just gonna do the first thing, memorial brick. I don't care. They need to have a material, right? So anything that you want to be in the daylighting model has to have a material applied to it. I'm not going to continue with that. It doesn't really matter for what I'm doing. But okay, so then I exploded all this stuff, and I created two separate layers. One being the opaque. Let me turn off the stuff I don't want. And so one being the opaque stuff, which is the exterior, and then the other being partitions. I also left the floor plates as part of partitions. That can make sense because um, this is a ceiling or a floor that is making up that's gonna if sun's gonna come in and hit come into one of these spaces, then this surface would reflect that sun, and so if it's more reflective than not, then it will reflect more sun and affect the daylighting in there. So I created that simple division, and then I kept your same glazing. But then what I did is I did this systematically, I just ran some tests. And, for example, I was having I was like, why is this one piece of glazing here um, different than these other three? And so what I ended up doing is just deleting that one because I tried it a couple times and it didn't. It was doing the same thing. So I took the first test I did is I took this surface, this window, and I just stretched it out the full width. I hid the others, and it fixed the problem. So then I realized, oh, okay, it's just this middle window. Something's wrong with it. It's not set on here correctly. I don't know. So I just solved it by deleting it, and then I copied this one and did a Control C, Control V, and just moved it over and made it the size I wanted it. Um, and for example, this window was not working for some reason. There were two in place here, so that could have been it. But there was absolutely no sun going through here, so I can't remember what I did here. I might have deleted that surface there and just rebuilt it. Just put another surface in. This is not rocket science and it's not magic, but there can be surfaces that get, and I don't even want to know what word to use. They're not corrupted, but I think that somehow in the complex math that's going on to create a daylight analysis, that something gets out of order or something, or whatever. So here's the point. You go in, you run a simulation, and this is what I did, is I just turned off everything except for my windows, and I put it and this, I know I'm in class, I'm saying I don't like to have colors on layers. That's not really true. That's not what I meant. Um, I don't like to have them for no reason. um, but sometimes the reason is to separate out, opaque versus glazed, or just like when I was building this up, um, I turned. That's why these are red, is because I just made my opaque layer red, and I just started bringing things over to it, and that was an easy way of. So, just trying to make a stream of consciousness video here, because I think that I just noticed when you were showing me stuff that you were um, trying to avoid making something a color because you thought I didn't like that, maybe. Um, anyway, so what I then did was I would run a simulation, and I went, and I should have showed you these. I just deleted them because there was a lot going on. Is I turned off, everything that except for whatever, So if I was testing um, this piece of glazing, I turned everything off except for this floor so that I would be faster. Um, one thing, this needs to be broken up. Like we're not going to probably have this. This is a quarter, I'm assuming. That's not going to be in the analysis, and you want to have just more control. So split this into a variety of individual work surfaces. I think you know what I'm talking about. If you don't, you can ask me. But then, so I went through and I just tested each of your floor plates separately as needed, so I could go do it quickly, and I troubleshot them. So that when I got to this one, I was just running this one, um, this floor plate or this work surface to test this window. Um, and I went systematically and found all the problems. And so that even goes beyond if it's working. I know this is going to happen with certain students. A lot of people just luck out, not luck out. They just do the simulations as I've taught it, and it works. And I think that's going to be 90% of the time, 80% of the time. And then some people are going to have a problem because for whatever reason, sometimes it's really easy that I can determine it. Others, it's not as clear, like in your case, because they're just because there were, I think, actually I don't know exactly why. Like I said, I fixed a bunch of different things, so I just think it's because it's a complex model and it wasn't built with simulation in mind. Um, but anyway, the point is that then people will run a simulation. It'll work. It'll look like it's working great, um, but there'll be confusing things like in yours over here that, why is this window different than these when they're both west facing? There's nothing blocking the sun out here. So you would want to, regardless, be troubleshooting this way, where you and this is how you're learning also from these simulations, as a student, not just trying to get something that meets a benchmark. You're saying, does this make sense? And if it doesn't, then um, you can just try fixing it by deleting something and replacing it. Or it might be you would say, oh wait, no, it does make sense, and this is why, because I have shading over here that I didn't realize, or I mean, there's a tree in front of this wall that I forgot about that's on, or whatever. All right. So the summary is simplify your model, do systematic testing if there's something wrong, and ask yourself, does it make sense? This to me now is making sense. Every single window has light coming in. I understand why, for example, on this, there's a lot here and none, and it's getting less here because these are the only windows in this large space. I understand why. Let me turn on. Understand why um, this though this might be something to look at. I just think this is a bigger window, so we're getting more sun into this room. This is we have partitions here, right? So there's a partition in there, so it's a very small space that's blocked around. So it makes sense, blocked by partitions. So it makes sense that there would be this small amount of light coming in, or less light than over here, and that it just stops right here because that's a partition. All the blue makes sense to me now. There's at present no reason. I mean, there's no light hitting the basement because there's no sun coming in except for right here. That makes sense. So you have this light well or whatever that is there. All right. So I will share this model with you. It's got your file name, and then I said FCS, Farley Clark Snell Edit 1, because I had another one that I did before that, so this is the second one. All right, let me know if you have other questions, and if there's other things I can do to help. I am here to help. All right, talk to you soon.